Question 1. In the figure above, what is the length of line segment AB? You're supposed to find this one. Okay, let's go over this question bit by bit, step by step. On the right side, we see one triangle for which we only have this information, the length of the hypotenuse. Why? Because this is a right triangle, right? So this is a hypotenuse. And on the left side, we see another right triangle. Notice here the icon. And for this, we only have an angle here. But then, if this angle is 30, then this must be 60. And thus, this is an interesting triangle that has proportions that are predictable. If the least side or the shorter leg is x, then the longer leg, that is side BC, should be x times the square root of 3, and the hypotenuse should be 2 times x. But I couldn't use these proportions in order to find any of the lengths in this triangle because I don't have any of the sides. I only have the combined sides of BC and CD, but I don't know which portion represents each. So I need to move back to the first triangle. If this angle is 30 and this is 90 degrees, it follows that this must be 60 degrees. Why? Because the combined measure of this triangle, this angle, must be 180 degrees. So 60 plus 30 plus 90, 180. But if this is 60, then it follows that this one here is 30. And we have the same type of triangle as on the left side. So we know that if this is, for example, k, this must be 2k, and this must be k times the square root of 3. Okay, but if 2k equals 8, that means k equals 4. And thus, this portion, the segment BC, should be the difference between 10 and 4. So x times the square root of 3 should be 6. All you need to do now is isolate the value of x. 6 divided by the square root of 3 is 6 times the square root of 3 over square root of 3 squared. And this is, this will be 3. So it's 6 times the square root of 3 over 3. You get 2 times the square root of 3. Option 2.